Hey guys, we're going to talk about shielded VMs today. Hey guys, and welcome to the show. We have our esteemed colleague and frequent Taste of Premiere guest, Brantley Whitley, with us. Brantley, what's up, man?
Hey Lex, doing well. Hope you are, sir.
Yeah, man, doing great. I see you shaved.
Yes, I did. It's
You
getting
know
too
it's
itchy.
no shave. It's no shave November, right? You know that.
I do, yeah.
Yeah. For me, it
Going
was no shave September, no shave October, no shave November. But it's getting close. I might shave. I'll just have to leave you in suspense.
yeah, go against the grain.
That's right. Yeah, I'm just going to wait till everybody else has a beard, and then bam.
That's right.
Hey,
Way to do
so you're going to talk to us about shielded VMs today, and I have to be honest with you. I don't know the difference between a regular VM and a shielded VM, so I'm really looking forward to talking to you about this today.
Yeah, thanks for having me. I'm excited too. Looking forward to covering the overviews, and maybe we'll do a part 2 and have some demos for this when I get my environment configured correctly.
Yeah, absolutely. You and I, for people that are listening to this, we actually talked about doing a part 2 before we started recording. So Brantley let the cat out of the bag, and that's awesome. So this will probably be part 1, and then look for a part 2 to this later with some live demos. So tell us a little bit about what a shielded VM is, and how is it different than a regular VM?
So that's a great question. If we take a look at our slide here, we talk about that a VM is essentially a file that runs on a hypervisor, and it's easy for storage admins, VM host admins, or backup administrators to copy that file off and perform some sort of offline attack, many different avenues to that file and inside of the file from the fabric around it. So what we're wanting to do here is put a good strong separation between the Hyper-V admins and the sensitive workloads that we run on Hyper-V, specifically things like domain controllers, because it's impossible to audit all of the different types and ways that you could copy the file or inject code into a specific VHD file. So that's really why we're interested in shielding the VMs.
Yeah, so it seems to me that one of the issues that I know my customers have had and some other customers have had with VMs was that they weren't really protected. And I think our guidance has always been, well, if you have physical access to any device, it's got the potential of being owned and being compromised. And so it looks like this may be a way to kind of prevent some of that.
Yeah, absolutely. And the new sort of paradigm now is that we're protecting the identity. You sort of assume that the environment is compromised from the get-go. You see that in Windows 10, Server 2016, as we're really into protecting the identity at this point. And this helps a lot of that separation around administrators in different roles. And even if a credential is compromised, we really want to make sure that we attest that the Hyper-V host is in a state that it was once it was attested that there's no malicious code running on it, and we can make sure that that data that's running on that host is encrypted and wouldn't be able to be powered up or accessed outside of a known good attested and measured host, VM host. That makes sense.
Yeah.
And then the requirements. So you mentioned earlier it's a 2016 feature or a role, and it is, and we'll go over some of the requirements here on the slide. So there's TPM attestation, and that requires a TPM 2.0, UEFI version 2.3.1c and above. The TPM attestation is really the most secure. So we're doing measured boot of the host, and we've got a chain that we can use from the firmware all the way up to the OS being completely loaded that's measured and hashed. And that chain is validated against a third party, and we'll go over the role that's measuring that and attesting it in just a few minutes. The host guardian service is in a few slides down, but we'll go over that. But the problem here with that is TPM 2.0 is fairly new. So a lot of hardware that you purchased recently may not have the TPM 2.0 hardware in it. So there's a bridge here with the admin trusted, which is essentially using a security group in AD for this service to make sure that you've said, okay, these machines in this group have been attested as best as we possibly can, and we're going to trust machines that are in this group to run shielded VMs. So it's kind of a bridge. The end goal is to get the TPM attested machine because that's the most secure. But we wanted to make sure that people could use this feature now with the current and existing hardware. There are a few caveats. I put the link in here about some of the code integrity features that would be required. So you can visit that link and check that out. But most modern hardware is going to be able to run the admin trusted mode. The host OS must be Server 2016. You can use Core or Nano. That's recommended for the Hyper-V host. And the guest VMs, you can run them shielded with Windows Server 2012 and beyond, anything beyond
So I can
Windows.
run a 2016 server but have a 2012 VM that's shielded.
Correct. Yes.
Hey, do you know, and you may not know the answer to this question, but I'm just going to ask anyway. UEFI version 2.3.1c. Do we know what makes that different than previous versions?
The reading that I've done on that actually last night was that there are some memory specifics on how memory is accessed around code integrity. I'm making assumptions that there are things in it that would prevent known types of memory buffer overflow and those types of things that were updated for this UEFI version. But the reading that I did was sort of light on the details, so I'm not, I don't have a list of all of the details around that.
Okay, that's fine.
Yeah.
I just wanted to see if maybe you knew, because I'm curious as to whether or not that would affect things like Windows to Go, etc.
Oh, yeah. That's a good point. I am not sure about that.
Yeah, no worries.
And then some considerations for performance. The product group looked at non-shielded versus shielded VMs and noticed about a 5% density impact around running a shielded machine, which makes sense. I mean, we're encrypting the data and we're doing the actual hosts, the processes that run the virtualization pieces inside of Windows Server 2016 are shielded too. Yeah, so running things like a debugger on the host to try to spew out information about the credentials or secrets that might be in memory for a given VM, that's blocked as well.
Cool.
On to the next. And so these are some of the benefits of running shielded VM. So you get BitLocker via TPM or virtualizing the TPM. You get hardened VM worker process, which is what we mentioned earlier. That it's you're not really going to get anything attaching a debugger to the process. And then you get encrypted live migrations, checkpoints, replica files, as well as the running state and save states are encrypted. With shielded VMs, we're going to block console access, so the Hyper-V console, and all of those things where you can drag and drop or copy and paste from the console. Obviously, that's a bad idea if you've got a sensitive workload running in a Hyper-V and you want to prevent malicious code or administrators from accessing the machine. So we're going to block console access, PowerShell Direct, and the guest file copy and RDP. So those things are going to be blocked when running shielded VMs.
So somebody wouldn't be able to remote in?
Let's see. So the Hyper-V host admin would not be able to. You would need to be a VM admin. So it's a sort of a delegation. Yeah.
So if you would have to have admin rights in the virtual machine itself.
Correct. Yeah. And you would need to be set up with another specific role for VM administration if you needed to access those machines. Yeah.
That's pretty cool.
Yes. Yeah. A lot of thought put into that. And what makes all this possible, obviously, is the VM host, so the hypervisor. The component that really does all of the checks and balances here is the host guardian service, and that's the unique service to Windows Server 2016. That's a new role, and I pasted the definition from TechNet. The product team wrote a really good article on the step-by-step deployment. And it's a role that is installed as a secure cluster bare metal server that is able to measure the health of a Hyper-V host and release keys to a healthy Hyper-V host when powering on or live migrating shielded VMs. These two capabilities are fundamental to shielded VM solution and are referred to as attestation service and key protection service, respectively. So that's back to where we're talking about in the TPM mode of attestation. We're able to take information about the UEFI BIOS, key material in the TPM, registers out of the TPM, hash those, as well as hashes of the bootloader and then the next binary, and then all the binaries in the operating system that load all the way up until Windows is booted, and then hash that again, and have that as an integrity check that sits inside of the host guardian service. And we need to check that back and forth, and they're signed. Each respective party signs it so that there's good secure communications and validity, to make sure that each host is doing the checks and balances and it hasn't been modified in transit, so to speak. So it's a really good way to measure that a machine hasn't been tampered with and there's no malware or some sort of product that would be messing with the boot process, like a rootkit or something like that.
Yeah.
And this is the steps that the host guardian service takes to validate that. So you can see in step 1 up at the top, the user requests to start a shielded VM, and the guarded host, which is our Hyper-V server, is going to look in step 2 and send information to request attestation. And over on the right-hand side, you have the guarded host service running on a cluster. So there's a 3-node cluster there. The attestation service evaluates the validity of the host and sends an attestation success back to Hyper-V. And the attestation certificate is sent to the host in step 4. Step 5, the host requests keys for unlocking VM1. And that's sent over to the host guardian service. Key protection service decides whether to release the keys to start the VM. And number 7, the keys to unlock VM1 are delivered to the host. And step 8, it's powered on. It unlocks the host and starts it.
Okay.
So that's a graphical representation of what we were talking about earlier. The details about the TPM are not depicted here, but that's how the TPM attestation really works in the measured boot scenario for the guarded host.
So it looks, is the host guardian service a service that we run externally that runs? Do I have to set up a host guardian service somewhere in my domain?
Yes, you do. It's you can install that role, and it's recommended in the deployment guide to run it on server core and to build a 3-node cluster for high availability. If you're going with the admin trusted mode, it's recommended that you set up a separate forest that's is pristine, similar to something like our ESAE. Offering where you have a really tight control over this because your keys are stored here. And if you go with the TPM attestation, I think you can stand it up in the same forest without having to do something, like a separate forest, because the TPM is a hardware boundary and you're not relying on the software logical boundary like Active Directory.
Okay. So I said that I guess the 3-node cluster is because if we've got mission critical services running in shielded VMs, we need to make sure that guy stays up.
Yes, you do. Sir, you wouldn't be able to power up your VM, so absolutely. Those need to be highly available. The deployment guide says do it on physical, so 3-node physical cluster so that you're not You wouldn't want to run the 3 on the same VM somewhere or virtual host. So 3 physical machines, 3 node cluster is the recommendation. And I think we cover this in our next slide deck. Yeah, I took this graphic from Dean Wells, the program manager, has a really good talk from Ignite, and I took a screenshot of this and put it in the presentation. I've actually got a link in this slide deck in the notes section. We'll put it out on the web as a reference material. But these are the 2 modes that we've talked about in the admin trusted. It's fairly easy. It's a PowerShell command to flip from admin trusted to TPM trusted. So if you don't have the TPM 2.0 modules and the UEFI 2.3.1 at the moment, you can still move forward with the solution. And once you have the hardware, you can run a PowerShell script to flip over and use the TPM trusted mode of attestation. So I think that's neat.
Yeah.
Really forward thinking.
You can kind of move between the 2.
Yes, yeah, and then you can decommission your Active Directory forest and the trust that you have and all of your DNS zone delegations and all of that, or conditional forwarders. You can remove all of those pieces and just move back to the TPM trusted. So you're getting a measured boot across all of your Hyper-V hosts.
Okay. Cool.
So really good stuff there.
Yeah.
So we want to switch over and talk about some of the modes of shielding. There's shielded, which is our recommended mode, because this gives you the most protection. You get the disk encrypted live migration. You get to use the virtual TPM to seal the keys. You get the block VM console, PowerShell Direct. This really means that you are looking for security. You don't trust that your storage fabric and your network fabric are highly secured. And so that's the shielded mode. Encrypted support is basically the use case for it most often is you need to meet a checkbox for compliance for data at rest. You still get VM console connection. You still get PowerShell Direct. You get RDP and all of the
BitLocker.
Yeah, you can get BitLocker. You can get live migration traffic is encrypted, and you can use the virtual TPM to seal the keys. But you do get the, it's more open, VM console, RDP, PowerShell Direct, all those things are still at play in this scenario, and it's less secure, and you're assuming that your storage fabric and your network fabric are highly secured.
Yeah. Yeah. The only thing that I keep coming back to is on the slide where we had the 3 highly available servers, the previous slide.
Yes.
There you go. The host guardian service. So if those went down, nobody could launch a VM, correct?
Correct.
Okay. Just making sure that we understand that.
Absolutely. And Dean makes a really good case in his Ignite talk about branch office. And he had a really good use case. If you have a branch office that needs a domain controller, and RODCs have their challenges. There's some limitations, and it's really difficult to use. And it's just, I don't know that many people have had a lot of success with read-only domain controllers. So, in this scenario, you could deploy shielded VMs in a branch office and leave your host guardian service in the hub, in the main hub. If the network connection goes down, you're going to have a problem rebooting. But if the machines walk away and the host guardian service is unavailable, then it's really, you're not going to be able to boot those machines. So if someone takes a server from a branch office and it is a shielded host, it's a guarded host with shielded VMs, you're really required to have that host guardian service online and available to unlock those keys.
Yeah, so that's a good point. So do we just unlock the keys once and then it's unlocked until we power it down and have to unlock it again?
It's my understanding in some of the documentation, and I'm not really crisp on this about what happens, but there is the initial certificate you get back, and the attestation certificate is valid for 8 hours. I don't know if that's configurable. I haven't completed my demo yet in my lab, but
so that's good. That's good. That was what I was getting at. Is so that cert has an expiration.
That is my understanding, yes, that it's 8 hours, and I'm not sure all the details, what would happen after the 8 hours, but I do know that it's very clear if you shut the machine down and the host guardian service is not available, those machines won't power up.
Right, that's the whole point, right?
Correct, yeah.
Yeah. Okay, sorry. Go back to the other slides.
Yeah, no, that was a great question. Thank you, yes. Thank you for the clarification, because that is important. It's highly available. It needs to be clustered, and if you go with the admin guarded attestation, the admin trusted, I'm going to recommend its own forest that is pristine and limited admin groups, so it would be outside of your day-to-day domain admin group. You'd really want to make sure that environment is super tight and pristine, but we're relying on Kerberos and a group to trust those VM hosts versus the hardware-bound keys.
Right.
So
I get it. And we're also relying on physical networking hardware, right? I mean, we have to be able to get to the cluster.
Correct.
But that's all good stuff. That's cool.
Yeah. Yep. So that was all I had for this. This pretty much covers it's a good summary of where we're at and sort of how all of the pieces tie together and recommendations. So it's a good summary of the step-by-step guide, as well as Dean Wells has a really good talk on the Ignite page.
Okay. Do you have a link to that stuff?
I do. It's in this in the notes section on the first slide, and we'll definitely get it out on the additional material.
Okay. Awesome. All right, guys. Well, Brantley, listen, thank you, man. This is cool. I can't wait for part 2.
Yeah, thanks for having me. I'm excited too. Hopefully, I'll get this going in my. I'm almost there. I'll get it going in my lab hopefully in the next couple of days, and we'll meet up again and maybe get a demo of what it looks like to try to start up, and I'll have some more answers around what happens after the 8 hours and get some of those things reproed in an environment so we can demonstrate what it looks like if the host guardian service is unavailable or we're past the 8 hours and it goes offline. So get some good screenshots and hopefully some demos of that next go-round.
Well, that's awesome. So there you go, guys. We're leaving this episode with a couple of cliffhangers. And I can't wait for episode 2 so that we can clear all that stuff up.
Yeah, likewise.
Yeah.
Looking forward to it.
All right, guys. So that's it for today. Thank you guys for watching, and that's your Taste of Premiere.